Hey guys, today I'm going to demonstrate how to do code analysis using Parasoft C, C++ Test Professional to an AR embedded workbench project. So I have here in my laptop attached a NUCLEO G071RB microcontroller. I'll be using the STM32Cube to create a test project for us. We can exercise the Parasoft and how the IAR IDE works with the Parasoft tool in terms of static and dynamic analysis. So I will use the STM32Cube to create an example project for us. So the board that is attached to my laptop here is a NUCLEO G071RB. And here we can see the examples that works with this board. I'll use this example here, the UART Hyperterminal IT. And initialize all peripherals with their default mode, yes. And here I will type the name of the project. It's NUCLEO G071RB. And here I will select the IR IDE version 8.5 and I will generate code. So this is the generated project, but I will close the CubeMX now. We don't need it anymore. So inside the EWARM folder is where the IR embedded workbench project file are located, the EWP. Okay, but we will navigate into that path using the command line here. So this is how it looks like right now. If we look for some files, let's just find, and there's no batch file. This batch file is going to be important later on. So in order for this bat file to exist, I will open the IR IDE. Sorry, this is the previous project. Let's close this. Oh my God. Okay, I hope I can still work on this. So I will open the workspace. NUCLEO, and here is the project file. Okay, so let me see if we have a bat file now. Okay, so we now have a bat file. Now we need this bat file to exist here, and it can only happen if we open the project using the IR IDE. We can close the IDE now, and we can proceed to the code analysis using the Parasoft IDE. But let me just explore a little bit further, and let me try to build this project. Okay, we're able to build it. And let's try to paste some blinking leads. In the while up here is empty, so let's paste it here and let's build it. And let's try to debug this just to test if our communication line to the board is working fine. I'll click this debug button. It's blinking, so that's good. And I will step over into the code. So lead on, delay, lead off, delay, lead on. So seems that the communication is fine. I'll stop the debugging and I can close the IDE now. Okay, so the IR IDE is not in Eclipse-based IDE, so the Parasoft plugin cannot be installed there. That is why we will launch the Parasoft IDE as a separate IDE to analyze this IR project. But before we can do that, we need to set some variable in the path. So I am in a Windows machine here, but I'm using get bash, so that's why my path looks like a Unix path. But the script that I run is this one, set IR path. So I export the path to where I install the IR in my drive C, specifically the common bin and the ARM bin. Okay. And then this is also where I install the Parasoft tool. As a result of this exporting of the path, now the IR build is accessible to my command line as well as the compiler of the IR, the C compiler, which is ICC-ARM. If I will launch a new command line here, and that would not be possible. Like, so unless you set the path in a global setting in your Windows, you can't do that. But here, I only set it in this particular terminal so I can access it. In addition to that, I also have access to the Parasoft CPP test trace utility. This utility is used to trace the build flow of project so that it can capture what are the C source files that is comprising the project. Okay, so first let us clean the project, as right now I think it has a lot of .o, right? So let us clean this, and the name of the workspace file is, okay, this one, and then this is also the name of the target there. So this is the target name. Okay, if you open the EWP file, this file, you will see this target name inside. It's like it's like a makefile target. It's like the all or the make all. Okay, so we'll clean now. So we clean 25 files. Let's clean and let's build. Right. So this will build the .o and the resulting .hex firmware for a microcontroller. However, take note that IR build cannot generate a BAT file. Just FYI. The BAT file can only be generated via the IR IDE. Okay, so instead of building it like this, we need to prefix it with the Parasoft utility CPP trace response file option -f. So let us pause for a moment what's happening here. This is the normal command to build the project, and we are prefixing it with Parasoft CPP trace command line utility. And this is how Parasoft knows what are the C source files that comprise the project. As it traces into the build flow, it gains and it learns what are the C source codes and the header files of the project. It will then create a BDF text file that has these listings of the files. I will press enter now. So it will build the hex firmware file as usual. And at the same time, it will build the BDF file that Parasoft can then use to identify what are the source files of the project. It is just a text file that is containing the list of the C source code of the project. Okay, so now that we have the BDF file, and if the environment where the ICC arm has been set globally in your Windows, then I can just right click, double click this Parasoft IDE here in my desktop. But that wouldn't be able to reach to access the ICC arm since my global setting is not set to know of these paths here. So I have to launch the CPP test IDE from the command line so that it can inherit the environment and be able to access the paths of ICC ARM. So I'll press enter here. So the IDE is launched and I will create a workspace, NUCLEO-G071RB. Create a project, select make file project with existing code. And in the existing code location, select the root folder of the project here. Finished. And then select this one, go to properties. In the Parasoft section here, go to C++ test build settings. And because we're using a BDF file to gain insight into the project, in the option source, choose use options from a build data file. And this is what is meant by BDF. It's a build data file. And then this BDF is already present as we have seen it a while ago here. It's already there. And then in the compiler family, it's still incorrectly set right now. It's using a x86 compiler. This should have been an ICC ARM compiler, right? Here. So we're going to expand the compiler family. And down below, we can see that there are settings for IAR. And we have a settings for IAR 8.5 version. Yes, and you can see these settings here are adjusted now. And because we launched the IDE from the environment here, which inherited the environment path variable, so this is how it can invoke the ICC ARM compiler that is configured here. Apply, apply, close. Okay. Now, a quick test to see if our configuration is correct is to perform static analysis. So right click in the stop node here, go to Parasoft, test using static analysis. And this is a C code, so it's not effective C++ because this is a C code. Recommended rules is probably the appropriate here. So I'll click recommended rules. Before I do that, let me enable verbose messages. By the way, here in the Parasoft preferences console, I will set this to high. Okay, in case there are error messages, we have more information. Okay, then I will right click again here, Parasoft, test using built-in static analysis and recommended rules. I can go to the console tab here and see the messages in action. So it's still 45%. It gave it some time. A successful static analysis is more or less indication that 75% of your configuration is correct, although it's still not, there is still room for error as you proceed to unit testing, but a successful static analysis is a good sign. So we have a successful static analysis, and you can see the result of the violations here, and we can double click, for example. It says here that the function main should have a return value at the end of the execution path. As you can see, it's not applicable here because in an embedded systems, there are a lot of infinite while loops. And if a violation is not clear to you, you can always right click to the violation and then view the rules. The ID here, such as the one in 16-8, is the exact section of the PDF in MISRA 2004 in 16-8. So this is a direct mapping of the MISRA rules. So it's a description here and some examples. Okay, so we can continue to run static analysis as there are around 5,000 static analysis rules here. Let me show you the listing here. In the static analysis, you can see it's 5,092, and they have been divided into different categories in compliance specs, such as in the automotive. Uh, these are the AUTOSAR rules. These are the MISRA rules in different incarnations from 1998, 2004 up to the latest 2023. There are also rules for medical devices pack and security pack. So again, total of 5,092 and sub uh, divided into these categories. Okay, compliance specs. So that's it. So we already executed the recommended rules, and that's it for static analysis. There are still uh, other two types of static analysis, uh, the metrics to measure cyclomatic complexity, and the flow-based analysis to detect divide by zero and array out of bound. But there are static analysis nevertheless. So delete these findings here, okay? And let's proceed to dynamic analysis or unit testing. The unit testing that we're going to do here is going to execute inside the hardware target. Take note the hardware target is a microcontroller. It does not have a file system. In situations where the target has a file system, such as if the target is an embedded Linux, then the result of the test execution will be written into the file system of the target. And then an SSH communication is usually used to copy back and forth these test results. Okay, but since this is a microcontroller, it's a little bit different, but the overall principle of copying files back and forth is the same. We copy the flash file, execute the flash file in the board, and the test results of that execution is copied back into my laptop. That is the overall flow. That is true if the communication is SSH or if the communication is serial. It's still the same principle. Okay, so we right now we still do not have a test case. So as you can see in the embedded systems, there are a lot of while loops littered around, such as, for example, uh, here. So we cannot just auto-generate these cases for all files in the project. Although Parasoft can do that, if I right-click here and ask it to auto-generate, it will auto-generate these cases for every function. But like I said, some functions have an infinite loop inside, so it might cause this case to hang, and there's special techniques to handle that. But to simplify this discussion, since this is an intro, I'll just create a small function that we can test. Here, I will create a function now, int addnum. It accepts two parameters, and it will add the numbers. If the two numbers are equal, then it will just return 2 times a. If not, okay. So this is the addnum function. Okay. So now that we have a function of interest that we need to test, let us generate uh, a test case just for this function and only this function. So I'll click main.c and I will generate a test container or a test suite. A test suite does not contain a test case yet. We can add the test case later on to belong under the test suite. So select the test suite. This test folder is now created and we have a test suite. If I switch to the test case explorer here, we have a test suite which is empty. And I will click this test suite and add a new test case. And here I can select the function that I want to test, and that will be odd num. Click next, and I can select what the value to pass to A and B. A is 3 and B is 4, finished. And this is the auto-generated test case where A is 3, B is 4, and odd num is being invoked. And there's nothing that's stopping from you to further add code here in this function. This is just like a C function. You can add more here. This is just the initial skeleton for you to start with. Now that we have this test case, the next thing is to execute it, right? Right now, since the embedded workflow is a little bit complicated, many protocols to use, many command to use depending on if you're using an IAR, a kill, or a Renesas or NXP. So we're going to customize the rule to suit our needs. So I'm going to click and this configuration here, and I'm going to use this generic template for IR. Here called the batch template. Since this is read only as it belongs to the built-in, we cannot edit this. See, everything is grayed out. We cannot change anything. We need to duplicate this. And once it is now under user defined, it is now time to modify. Now this one takes a little bit time of trial and error. As you can see in the bat file, I was let me see Nucleo G0. Okay. This concatenation of the bat file is going to be um, the Parasoft IDE as it analyzes is going to locate this, and through trial and error, it took me some time to figure it out. But this folder here, EWARM, is the one that we should put here. Okay, there. And how I figure it out is if this one is incorrectly set, then you will see in the error message that it's looking for the bat file in a weird location. And that is how, through trial and error, I just try that if I put EWARM here, then it will be the one that is used here. In fact, this second string here is also the one that is being used in this here, NUCLEO-G071RB. Okay, so again, if you incorrectly set these two guys here, you will encounter an error message that this bat file cannot be found, and it took me some trial and error to figure it out. Now, the reason for this is the IR IDE has evolved over time and it changes the location of certain certain things. So that's why we cannot blame the tool of not being able to correctly set. This is also the reason why we need to configure the test configuration, as it does not know where things are. So these are things that you still need to customize. But it's good that Parasoft has figured out that such thing is areas where things are changing are configurable, so we can still find work around with it. So after after setting these two values here, I'm gonna apply and close. So now that we have created a custom test case, I will right click the test suite and then I will be using the user define where I customize the setting that matches our current project. Embedded systems, IR systems, this one. I'll select this one and let's wait for the test case to run. It will blink when it's trying to copy or to flush the hex file. It's blinking now. It's also executing the test case in the board. The board is slow, 16 megahertz, I think. So the Parasoft ID is waiting for the board execution to complete. And once it's completed, it's copied back the test artifacts, that test results log, coverage log, and test results test log are copied back into my laptop into that certain location where the IDE can find it, and it will okay, something is wrong here. Let's go to the error. So there is a timeout here. Timeout means that the execution of the board took some time, so the IDE has to kill it. There's a timeout setting that we need to increase. The board takes some time to complete. It's just a microcontroller. It's slow, 16 megahertz. So let me increase the timeout. First, let me delete this error here. And I will go back to the disk configuration. And in the runtime, I'll change this to 50 seconds. And I will rerun again, test. Test using there. So let's see. So now the Parse ID is waiting for the microcontroller to finish execution or copying of the hex file, executing it there, and copying back sending back the results to the laptop. So it's sending in chunks, in small chunks. So you can see it's still 63%. Can see it in the IDE at the bottom part, and it's completed. See, A A is 3 and B is 4, and that is why we didn't went into the line 57 because our test case does not will not lead into that condition, right? Uh, Here we can generate a report like click configure and select HTML, apply, apply close, OK, and this would be the test results. By default, it only have line coverage. And the one that we are testing here is odd num function. So here 67%. The rest are zero because we're not testing those. We're only testing odd num. So line coverage is the default, 67%. To add other type of coverage, first let me delete this. So I'll go back to the disk configuration and I will enable more coverage. By default, line coverage is the only coverage type enabled. I will enable function coverage and statement coverage. So we now have three coverage metric types. We still have other covers. I think there are 12 of them or more than 10. So I'll just enable 3. Okay, apply, close. And let me rerun the test now. Select test using. Okay. So this time it will take a little bit longer because three type of coverages are operational: line, function, and statement coverage. Okay, so this is what we saw a while ago, that if we generate a report this time, and here we can see that there are now three columns: line coverage, one for line coverage, another one for statement, and another one for function coverage. And this is the value for the odd num function under test. See here that it's 100% for function coverage, 67 for both line and statement coverage. So how do we increase let me delete this. How do we increase the coverage matrix then? So we need to generate one more test where it will hit line 57. A situation where if A is equal to B, then it will hit line 57, right? So right click here, add new test, and then select odd num, and then A is 5 and B is 5. Finished. So now we have two test cases. So let me clear the cache. Okay. Uh, Let me run again the test case. This time we have two test cases and we have three coverage metric types. This using user-defined embedded systems. Okay. Hmm. Okay. You can see we now have 100 covers all in green. As usual, I will generate a report. And this time we have 100% across each type of coverage since our test case is completed to hit every line of the function under test. So that is it. Let me review some highlights. First, the thing to note is this batch file need to be present. That can only happen if we open the project using the IR IDE and do a build. That's first. And second, in the Parasoft disk configuration here, this entry here needs some trial and error. And these two here are concatenated to form the path of the bat file. Okay, if there's a failure to correctly set this entry here, then the bat file cannot be found, and you can see the in the error message lag some weird path, some weird location, and that is how I figured out that by trial and error I was able to form the correct path uh, here. Okay, so that is it, guys, for today's session.